So, hello viewers, you're welcome once again to my YouTube channel. And in today's topic, we're going to be talking about welding coil. Now, if you remember yesterday, we mentioned that we have two types of current in welding. At the end of our topic yesterday, we said we have the AC current, which is the alternating current. And we have the direct current, which is the DC current. And then we have the DCEN, that means the direct current, electrode positive, electrode negative, and then we have the DCEP, the direct current, electrode positive. But first, the one will ask, what is current? Of course, we all know from physics, from electrical, current is the flow of charges of electron on a conductor at a particular point. But that's not where we're here. We are talking about current now in welding. So we have the alternating current, which is the AC current, and we have the direct current, DC current. And so we have the direct current electrode negative, we have the direct current electrode positive. And of course, you know that one of the characteristics of the AC current is that its flow, its pattern of flow is sinusoidal, meaning it is pulsating. On the wave diagram of the AC current, you have the current in this manner. Then for the wave diagram of the DC current, you have the current in this manner. It's a positive region. You have the current in this manner. Meaning for the DC current, if you will change the polarity, just like we have the DCEN, which is the direct current electric negative polarity, the DCEP, if you have the direct current, you have the direct current electric positive polarity. Meaning if you change the current, the effect, the output you will have in the process of your welding will change. But for the AC, you know that the current is at one point is on positive polarity, at another point is on the negative polarity. So we are not so much bothered about the alternating current, but here now we are bothered about the flow of the direct current. Now, in the direct current electronegative, means that your electrode is connected to what? And your electrode, your tongue, your lead cable is connected to the negative polarity, while your work clamp is connected to the positive polarity. And we are told that in the direct current electronegative polarity, it is also referred to as the straight polarity. And in this straight polarity, we are being told that on the anode, which is the workpiece, you have 70% of your heat at that point. On the cathode, which is your electrode, you have 30% of heat generated on this point. Now, how does it apply to welding? Now, for the direct current electropositive, this is the reverse of this. It means at this point, you have 30% of your heat, and at this point, you have 70% of your heat. That is the direct current electropositive. How does it apply to welding? Why are we looking at this in welding? For each electrode you use in welding, it has its type of current. And its type of current means its type of polarity. An example, the E6010 electrode will require you to use a direct current electrode positive polarity, which means instead of the straight polarity, you'll be using what we call the reverse polarity. This is called the reverse polarity. So instead of a straight polarity, you'll be using the reverse polarity. And in this case, the straight polarity, you discover that this direct current electronegative polarity helps us to avoid what we call bond-through, troublesome bond-through, open bond-through, a situation where you're welding, and at the point you are beginning to discover that your keyhole becomes wider than normal, and your multimeter begins to flow behind hook. And then for the direct current electropositive polarity, it helps us to achieve the effect of a lack of fusion. So we avoid lack of fusion by using this direct current electropositive polarity. So it is required for you as a welder to understand the principle behind this, to understand each type of electrode, the type of current you are required to use in welding. At this point, I want to once again encourage you to like, to subscribe, and to share this channel. While we go on in our lesson, one other thing I would like to discuss in this lesson is some very important things, such as what we call the striking voltage, the open circuit voltage, and the arc voltage. The striking voltage simply refers to the minimum voltage at which an arc will be struck. In other words, the minimum voltage that is required to initiate an arc. That is what is called the striking voltage. While the open circuit voltage or the terminal voltage is the voltage at the terminals of the welding set, which is ready to be utilized in the process of welding. While the arc voltage is the voltage between the electrode, or the voltage between the tip of the electrode and the billet metal in the vicinity of the welding, or in the vicinity of the arcing. So this is the arc voltage. Now, how do we use this in welding? How does this apply to welding? This applies to welding in what we call the dropping characteristics. The dropping characteristics. This is the diagram of the dropping characteristics, where we have here to be the voltage, here to be 100 volts, where we have here to be the current to be 50, 100, 150, 200. The voltage here could be 20 to 40. And then characteristics, we have the voltage to be 100 volts. Then we now have the current, the maximum 200 here. So the dropping characteristics tells us that is the effect of the open circuit voltage, which drops automatically from the terminal voltage to the arc voltage the moment an arc is short. So it tells us that the open circuit voltage, which drops automatically from the terminal voltage to the arc voltage the moment an arc is short. And then this is what? This is constant. While this drops, and this is the effect of the stability of the arc. So in our next video, we'll be talking about how to select the right current for the job. See you in the next video.